In this video, we are going to do some practice questions where we are going to face expressions and we are going to draw the logic circuits by using only NAND gates. Okay, so let's start with the first question. Let's say Q is equals to AB plus BC plus AC. Okay, so how can you do this? Well, I taught you how you can work with OR gates, right? I mean, you just need three NAND gates to create an OR gate. Okay, I'll just attach the link to the description. So you can either look at it like that, or you can make some rearrangements or arrangements. Yeah, not rearrangements. You can make some arrangements so that it works for you. Okay. So here we have AB plus BC plus AC. If I use double negation here, if I use double negation here, what I will be left with is AB plus BC plus AC whole thing double bar. Now I can break single bar by using the De Morgan's law. So which will give me AB whole thing bar into BC whole thing bar into AC whole thing bar. So now we have the form, the expression is in the form where we can use only NAND gates. Okay, where we can use only NAND gates to come up with the circuit. Why is that? Here we have a NAND gate for A and B. Here we have a NAND gate for B and C. Here we have a NAND gate for A and C. And finally, all these terms are put together inside a single NAND gate. So this is how you have to think. Why am I teaching so deeply into this? Is because we have to ensure efficiency when we are working with these things. Okay, so make sure you use the minimum number of NAND gates when you are performing questions like this. So let's draw this now. Okay, so let's draw this now. So we have the signal line for A, B, and C. Okay, we have the signal lines for A, B, and C. First of all, let's get AB whole thing bar. So let's have A and B sent through a NAND gate. Okay, so this is the NAND gate. And then we have BC whole thing bar. So this is B and this is C, and they are sent through a NAND gate. And finally, AC whole thing bar. So we have A and then C sent through a single bar, whole thing bar. So now we have to have these three signals sent through a single NAND gate to find the final answer. So let's send them through a NAND gate so that we can find the answer. How did I do this? Well, I just looked for how I can change the expression into NAND gates form. Okay, I need something like, if there are two signals or multiple signals, it doesn't matter. I just need the signals in the format AB whole thing bar whenever possible. That's all I need. Okay, it can be even A bar B whole thing bar. It's fine. Since we can have a NAND gate to convert this into, I mean, we can use one single NAND gate and it can act as a NOT gate. I can actually have this also. Okay, instead of plus signs, okay, I am looking for dot signs. That's all what I'm going for. So this is how you have to do this question. Okay, now let's do another question. How can we do this question? Well, first of all, just think of it. Okay, I just need the NAND gate format. It has whole thing bar and then dot sign. We have plus sign. So first of all, let's just try to remove that. So we are going to double negate things. Okay, we are going to double bar this thing. So we have A bar B plus AC. I can break a single bar, which will give me A bar B whole thing bar into AC whole thing bar. Great. That's all I needed. Why? Here we have A bar. Well, that's a NOT gate, and that can be created simply using an AND gate. And then here we have a whole thing bar, which is a NAND gate. Here also the same story, a NAND gate. And then here we have another NAND gate. So totally 4 NAND gates are required. That's it. So let's start drawing the diagram. So we have A, B, and C. So let me draw the signal lines. Okay, I don't actually know what they are called. Okay, I just call them signal lines so that it's easy to understand. That's all. So let's send A bar. First of all, we have to create A bar. So how can we create A bar? Well, we have to send the same signal twice through a single NAND gate. Okay, now you will have A bar. A bar B. So let's send B and A bar through a single NAND gate. Okay, and then A and C through an AND gate also. Okay, let's send A and then C through a NAND gate. Now we can send them through another NAND gate and we can be done with this question. That's all. That's all. So this is how you have to draw for this question. Now let's do another question. So now it's for you to try. Okay, without even drawing, can you try and tell me how many NAND gates are required minimum, okay, to complete this circuit? Well, let's talk about it, shall we? How can we do this? Well, this is how we are going to do. Here we have plus sign and we hate plus signs. Okay, so that's what we are going to remove first. So we will double negate things and then break it. So you will get A bar B whole thing bar into C bar. Do you agree with me? Why? So this double bar means nothing actually. And then I can break a single bar and then that will give me this specific output. And that's it. The question is solved. Why? Here I have C bar, which is a NOT gate. So I need a NAND gate for that. And here I have A bar, which is another NOT gate. So I need a NAND gate for that. And the A bar B whole thing bar is there. So that's a NAND gate. So the count is 3. And finally, these two signals, okay, these two signals are sent through another NAND gate. Okay, so that's it. Just 4 NAND gates here also. Let's draw the logic circuit. So we have the signal lines A, B, and C. First of all, A, B, finally C. And we have to send A through a NAND gate. So why am I saying it's a NAND gate? Well, this NAND gate acts as a NOT gate. Okay, that's all. And then we have B that is sent through a NAND gate with A bar. A, fine. Then we have C bar. So let's send it through a NAND gate, which acts like a NOT gate. Okay. And that's it. And finally, these two are sent through another NAND gate. So if you look at this, okay, all the 3 questions that we did, they just required 4 NAND gates. But the expressions were a little bit different. Okay. First one looked a little bit long, AB plus BC plus AB plus BC plus AC. But here we have only A bar B plus C. Okay, so whatever the expression is, if you can rearrange it properly, okay, you can do the questions without any issues. Okay, so what's the trick for doing these questions? Well, if you find a plus signal, okay, something like AB plus CD plus EF, something like that, just make sure to draw 2 bars over the signal and then break the bar here. So you will get 4 NAND gates. That's it. So keep this in mind when you're doing questions. Don't forget this. And in the next video, we will be focusing on NOR gates, another type of universal gate, and how we can do the questions there. And that's it. So stay tuned.
Thanks for watching the 23rd video in our Logic Gate series. If you found this guide to drawing circuits using only NAND gates helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos, check out the full playlist to master Logic Gates, and follow us on Instagram. I will see you in the next video. Until then, keep learning and stay curious. Bye-bye.